Bismillahirrahmanirrahim. AS level trigonometric ratios. Now the topic is trigonometric identities of negative angles. If an angle is, we have done positive angle and negative angle and reference angle or basic angle. So if there is a negative angle and we want to change it to a positive one, then how can we do that? So here, if I simply draw this grid, this is x, positive x, and positive y. This is very important to understand that these are positive and negative signs of x and y axis. So if there is a line here making an angle theta, then this value from here, this much, that will be represented by cos theta. So this is cos theta. If here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If I draw a line this way, then this is angle of same magnitude but clockwise. If anti-clockwise angle is there, that is positive angle. If it is downwards this way, that is negative angle. Now for this much value, for this value, if this is cos theta, then downwards that will be minus cos theta. Or in other words, let's say if this length is r, then this value will be r cos theta. This value here, that will be r cos theta. I remove few of these things from here, and let me change the color. This length is r cos theta. If we consider this triangle upwards, this is r cos theta, and if we consider the triangle downwards, this length, this will be r cos minus theta. From this side it will be r cos minus theta, and from the upper triangle this will be r cos theta. So this is the value of r cos theta or r cos minus theta. In both of the cases you can see that since both are moving this way towards right, therefore their length is same. So r cos theta, you can say that is equal to r cos minus theta. R is cancelled, so you can say that cos theta is equal to cos minus theta. Or we can say that cos minus theta is equal to cos theta. Value of cos minus theta and cos theta, they are same. Okay. And the reason is that in the first quadrant or in fourth quadrant, in both of these quadrants, on the right side x is positive. So wherever x is positive, cos theta is positive over there. So in these two quadrants, cos theta is positive. So cos minus theta, if it remains in the fourth quadrant, its value will be positive. And cos theta is already positive. Okay. Now for sine theta, if we consider sine theta now, you can see that this is sine theta upwards. This is r sine theta. This one downwards, this is r sine minus theta. So if it is downwards, it will be, now look, if this is r sine theta, if direction is changed, this will be minus r sine theta, right? Because of change in direction, if this is r sine theta, and this is the concept of vectors actually. If this is a vector A, then this is minus A. So in the same context, if this is B, then downwards that is minus B. So if this is r sine theta upwards, then downwards that will be minus r sine theta. So what is the value in terms of negative theta? R sine negative theta. So you can say that r sine negative theta, its length is equal to r sine theta, but this one actual r sine theta is upwards, so downwards it will be negative. So once again r is cancelled, then sine minus theta is equal to minus sine theta. And look, once again, cos minus theta is equal to cos theta. This is not equal to minus cos theta. And the reason is that cos theta and cos minus theta are in the same direction. Here there is difference of direction, whereas length is same. Whatever is the length upwards, it is of the same length downwards. So lengths are same, but direction is different. For that reason, sine minus theta will be equal to minus sine theta. Direction is changed. For cos theta, direction does not change, so it remains cos minus theta, and cos theta will have same value, but sine does not. Similarly, tangent minus theta and tangent theta. Now, as I have suggested earlier in other videos, that it is better to understand tangent with reference to gradient. So once again here, you can see that gradient of minus theta is this way, which is negative, and the gradient of this one is positive, whereas magnitude of gradient in both of them, that is same, because opposite is equal as well as adjacent is common, so value is same but sign is opposite. That's why tangent minus theta will be equal to minus tan theta. So combining these three ratios, three identities, that cos minus theta remains cos theta, where sine minus theta, that becomes negative sine theta, and tangent minus theta, that becomes minus tangent theta. So this is the identity, and sometimes some students get confused about the angle more than 90 degrees. Like if the line is here, then this angle is 120, and equivalent to same angle, if line is here, this angle is minus 120. So once again we can say that cos 1 minus 120 is equal to cos 20. Cos of minus 120 will be equal to cos 120, and the reason is that cos 120 is this way. Now it is on negative side, and cos minus 120 is also on the same side, negative. So cos minus 120 will have answer minus 1 upon 2. This will also have answer minus 1 upon 2. So it is true not only for the angles within first and fourth quadrant, but anywhere else where whatever is the value of theta and minus theta, it does not make a difference whether they fall in first and fourth quadrant or second and third quadrant, wherever, but they will be the same. So this is the identity. If you remember that this identity, then I hope that many things will become easier for you. So there are few more things which we will keep on discussing in next videos. So this was only about the negative angle. So wish you all the best. Allah Hafiz.